Thank you, Asha. Our next contestant is Allison Osmanson. Her department is Materials Science and Engineering. Her advisor is Dr. Witold, Brostow. The title of her project is Defining a Relationship Between the Flexibility of Materials and Other Properties. Allison, take the stage.
A few years ago, I was off-roading in the San Juan Mountains of Colorado with my family, overwhelmed by the stench of gasoline leaking from our fuel line, which was made of plastic instead of steel. We were in the middle of nowhere with no cell service, and the nearest town was at least a day's hike away. Fortunately, we were a team of engineers and were able to solve the problem using duct tape and hose clamps, and were able to drive to the nearest auto repair shop. In retrospect, the problem could have been avoided entirely. Sure, we could have just not been doing this. But considering the harsh weather conditions, combined with fluctuating temperatures exposed to the plastic, and the poor choice of material selection, this failure was only a matter of time. Engineers involved in design could have chosen a material more suitable for its purpose, and they could have done so by the increased availability of information about the materials they could use. This is where my research comes in. I determined various mechanical properties, including the strength of a plastic, how well it recovers after it's been applied to a load, and how susceptible it is to friction and wear, as well as how much it expands when it's heated. I used all of these components to derive an equation to define the flexibility of a material. This equation could be used to characterize plastics further than they already have been, as we know now. I took my work a step further, and I determined how a plastic responds after it's been exposed to harsh conditions. I did this by exposing plastics to various solvents for 24 hours. And then afterwards, I evaluated whether or not it became more brittle or more flexible. In some cases, it did become more brittle, and in other cases, it did become more flexible. Understanding how this happens could help material scientists and engineers evaluate how long a material will last in its mechanical application and when it will need to be replaced. More importantly, it also helps them determine how they're going to improve the material through processing. Gaining this sort of understanding can be beneficial to automotive, aerospace, and electronic industries, as well as their consumers. More specifically, it will protect adrenaline junkies, such as myself and my family, from being stranded in the middle of the mountains, like we were in this case. Thank you so much for listening.